Hello, I am Hamida Rebai. I am Microsoft MVP in Developer Technologies, and today we will talk about modernizing your application with API patterns. So we'll present the different strategies for modernizing an application using API patterns and technologies, and the need of having an API management in the cloud internally for your local solution or in the cloud. We talk here about an hybrid environment, and we will cover an example of legacy modernization with APIs using one API gateway, more than one API gateway, and we will cover building a new application using microservices, for example. So I am Microsoft MVP, as I said before, in developer technology, solution architect, and member speaker in .NET Foundation. I'm also Microsoft certified trainer. I am Azure certified and also book author. We present in the end maybe the links of my books that can help you complete your learning about APIs, patterns, and building your application using API approach and API management also. Here I have different links for my Medium blog, LinkedIn, YouTube, Twitter. So if you have any question, even after the session, you are able to reach me using these links. So the table of content today is really simple. We will start talking about API definition, API types, what is the API foundation that we need to consider before working on building your APIs to be able to modernize your applications, API gateway patterns, and we will finish by presenting an example of API management that is in Azure API Management Service. So what is an API? API, or Application Programming Interface, is a set of programming structures and protocols used to enable communication between software applications. Essentially, an API acts as an intermediate that facilitates interaction between different software programs by defining how they can communicate and exchange information. APIs have become increasingly important in the modern software landscape, as they allow developers to build complex systems that integrate with other software application systems or services and platforms. APIs allow software developers to leverage the functionality of existing software application and services rather than having to build everything from scratch. You can save time and efforts and allow for more rapid development and innovation. We have multiple key components in APIs. For example, the first is that API itself, which acts as an interface between different applications. The API may consist of several components such as authentication, authorization, mechanism, data models, and request response formats. Overall, APIs are crucial for a modern software development, enabling integration between different application, platforms, and services to create more powerful and interconnected system. This is an overview about API, a simple definition need to know before start adopting, let's say, the APIs, talking about different patterns, talking about how we are able to work with APIs, and now we'll talk about the different types of API architecture. So we can also understand APIs in terms of their architecture. An API's architecture consists on the rules that guide what information an API can share with clients and how it shares the data. REST, SOAP, and or RPC, for example, are the most popular API architecture in use today. Let's start by the first one, that is the REST, the most used, and we know it, we use it even in .NET, for example, ASP.NET, we have Web API with REST or any other language. So the majority of web APIs are built on REST. REST, which standards for representational state transfer, is a set of guidelines of a scalable, lightweight, and easy to use APIs, known also RESTful API. It's an API that allows REST guidelines and is used for transferring data from a server to a requesting client. We have some guidelines to consider if we talk about the rest. The first one is client server separation, which means that all client server interactions must be in the form of request from the client followed by a response from the server. Servers can request and clients can't respond. Another, let's say, guideline to consider also is uniform interface, which means that all requests and all responses must be in HTTP protocol using HTTP as the communication protocol and be formatted in a specific way to ensure compatibility between any client and any server. So server response are formatted in JSON or JavaScript or object notation. This is the format. Another guideline that is stateless. Each client server interaction is independent of every other interaction. So the server stores no data from client requests and remembers nothing from the past interactions. We have another guideline that is layered systems where the requests and response must always be formatted the same way, even when passed through intermediate servers between the client and the API. Cacheable server responses should indicate whether provided a resource can be cached by the client and for how long. So if you follow these guidelines, REST APIs can be used for quick, easy, secure data transfer, making them a popular choice among developers. Now, we will talk about the SOAP or Simple Object Access Protocol. It's a protocol for transmitting data across networks and can be used to build APIs. SOAP is standardized by World Wide Web Consortium and it uses XML to encode different information. So SOAP strictly defines how messages should be sent and what must be included in them. This makes SOAP APIs more secure than REST APIs, although the rigid guidelines also make them more code heavy and hard to implement in general. So, for this reason, SOAP is often implemented for internal data transfers that require high security, and the most flexible REST architected is deployed more commonly everywhere else. But one of the different advantages of the SOAP is that it works over any communication protocol, not only for HTTP. It's now similar to the rest that we talked about before. We have also GraphQL API. It's developed by Meta in 2011, and it's an open source. It became an open source in 2015. GraphQL API is defined as a query language for APIs. So GraphQL allows for requesting clients to receive exact data rather than a fixed structure of data from requests performed with a traditional REST API. Now we'll talk about API modernization approaches that is divided into four phases. The first one, it's a API strategy. We build an API program. The second one, it's about API management, API governance that we need to set up inside the company when you would like to work in API, developer engagements, and API cost model. We focus more about API strategy in our case now. So the first, because it's really important to work in your API strategy to be able to modernize your application, to build your modern application using APIs. It can be for your monolithic application or for your microservices application that will use your APIs or any other type of application. So an API strategy should be in place in order to expose which set of data services to API consumers. For example, we give an example for some APIs that is used in the market, external facing APIs, process APIs, or system APIs. An API strategy is a critical component of digital transformation. We will start by defining an API strategy. We start by defining uh, we set our strategy. It includes the types of APIs you will use, the security protocols, and you will employ and the process different processes for integrating and testing your APIs. Defining an API strategy will involve setting a clear direction for how your organization will design, build, and manage APIs to meet business goals and customer needs. So, we start by building a strategy view of your APIs, API vision in our case. After we align organization and the culture, here we need to focus about API mindset to make we need to change the mindset of organization, the culture internally, leadership, and investment also. We evaluate and build supporting tech. In this case, we need to have right metrics in the digital value chain. And we need to be engaged in the current ecosystem, which means that we need to maintain and optimize as you continue to use your updated application, monitor its performance and user feedback, and make ongoing updates and optimizations to improve its functionality and usability. So, this is about API strategy. Having a good strategy will help organizations to build their own API program, and we need to establish in the beginning a digital strategy, which means that is one stage in the API strategy blueprints, because it's critical to the success of the rest. So this step is really important because the strategy will morph over time. It will serve as your north star for the other three the other stage that we mentioned it before. So your digital strategy development will be theoretical since it relies on digital and instincts and creativity, which can pose challenges for the many organizations. So we start by identifying the business outcome, which means that stakeholders should plan their key organizational competency and identify areas where they may run into problems to help direct the digital strategy and establish business outcome. After we identify your target audience, so here we need to have an idea about the API ecosystem. This is why we need to identify our internal, external client, let's say, or participants. And in the end, we need to validate ecosystem and business models. That is the best ecosystem. We have added value in our case to build our ecosystem. After working on the strategy, the different elements that we talked before, now we need to align organization and culture. We said before, we have an API mindset to make change. So we align organizational culture. This part is also critical component of development and effective API strategy, because we have a full lifecycle API management platform that will include to set up that will include a set of tools that help organization to design, develop, deploy, and manage their APIs. We have many components to consider in this step, and when we'd like to align organization and the culture, we need to consider these elements like API design tools, API development tools, API testing tools, API deployment tools, API security tools, and API monitoring tools. So we need to cover all these elements before working on the culture of the company. They are the foundation that we will see after, different foundation related to the APIs. Now it's time to evaluate and build supporting tech. It's another step. It's important part of developing an API strategy because we will evaluate existing infrastructure. We start by evaluating the organization existing infrastructure. We identify any gaps area to improve, and this may include evaluating your current technology stack, such as your server infrastructure, data storage, and API management platform. So we need to identify also the necessary technology to support any API program. It may include technology for API design, development, testing, deployment, management. We need to consider the specific needs of any of your API program to add it internally for your strategy, such as security requirements, performance needs, and scalability. And we have to keep working on the research, assess the different technology options that are available to support your API program. This may include evaluating different APIs management, platform, programming language, and framework. And we need to prioritize different technology needs for your API. And in the end, we need to build support tech by identifying the necessary technology and evaluating the different options. We know after all this step, we need to continuously evaluate and optimize. It's a work continually. We need to evaluate, optimize the support tech to ensure that it is meeting the needs of your API program and supporting your strategy goal. Now it's time to engage our current ecosystem because it's important also in our API strategy. And to do that, we have some key consideration for to engage your ecosystem in your API strategy. The first one is about developer experience. We need to provide a good developer experience because it's crucial for engaging the developer community around your APIs, which means documentation, sample code, tutorials, and any other resource that make it easy for developer to get started with your APIs. Another element that is developer outreach is additional to providing resource for your developer. You need to actively reach out the developer community and build a relationship with them. Another element important that is related to partner programs that can help you engage partners and other stakeholders in your ecosystem. Now we see briefly the API foundation, that is basic set of principles and best practices. It guides you in development implementation of your APIs. It can include consideration related to front-end integration, backend integration, and different types of APIs like public, community, solution, internally APIs, and any API description. So the first one, that is front-end integration. It involves integration API with front-end application to create effective user-friendly application. So effective API design, security, documentation, data format, and error handling are all important consideration for front-end integration. For backend integration, this involves integrating your APIs with backend system and application. So API foundation includes the different best practices for API design, security, documentation, data format, also error handling, testing, versioning, and management. And we have in API foundation different API types. For example, the first one is public APIs that also call it external or open APIs. These APIs are available for anyone to use with little or no restriction through many requires registration or and authentication, for example, and are generally easy to access because they are intended for the public to use and designed to encourage new use cases and integration. We have community APIs that are open to specific community for group or group of developers, such as those who are building application for a particular platform or ecosystem. For example, of community APIs, it can include APIs provided by, we give an example of Salesforce, exchange ecosystem, for example. Solution internal APIs are used within an organization to connect different systems and application, and these APIs are not exposed to external developer or end user, and are typically used to support internal workflow and processes. And we have API definition that refers to the different documentation that will describe your API functionality, resource, parameter, response format, and any other important details needed for the different users. So when developing application based on complex or large microservices established on multiple client application, we recommend to use API gateway. API gateway pattern is an integration pattern for client that communicate with a system device designed to provide a single abstraction layer between the underlying services and the customer's needs. So what we need to consider when you will use the API gateway pattern, we need to consider a synchronize the response. It's issued by system making the call. Dependency between microservices are manageable and do not change over time. No latency requirements. There will be no critical issues if there are slow response, and they are needed to expose an API for the purpose of performing data collected from various microservices. Here we have the different features to consider of API gateway. So, for example, for routing, the API gateway acts as a reverse proxy and routes a request to the appropriate API based on the endpoint HTTP methods. So, reverse proxy, gateway routing. So, this is about routing, request aggregation. It's another part of gateway aggregation. It's another part of this pattern because we can aggregate multiple internal microservices into single client requests. So the client application will send a single request to the API gateway. After that, the API gateway will dispatch several requests to the internal microservices and then aggregate the results and send everything back to the client application in one single response. We have authentication authorization, service discovery integration, response caching, retry policies, circuit breaker, rate limiting, load balancing. Here, the for load balancing, for example, the API gateway can perform load balancing to distribute requests across multiple instances of the API. Logging, tracing, correlation, header query, string, and claims transformation. So we have multiple features related to the API gateway pattern. Here we have a use case that we will use it just to show you what is the problem. In our case, you see that we don't have any API gateway. We have multiple. We have a client web application. We have a user. We have a mobile application. So here we have multiple services, and we need to understand the problem related to the direct communication between the client application and the different APIs or microservices that are APIs. So, which certain we have front end, back end, it's APIs in our case, for example, and will interact directly with the client application. In our scenario, the client apps must send requests directly to the microservices, and we have multiple interaction. But if we add an API gateway here, an example of having one API gateway. It's simplified with one. It can be along with advantages of using the API gateway pattern. We have some elements to consider. So you see that the API gateway will dispatch a different interaction. It will be easy for to manage the different calls comes from the mobile application or your any application. So the user or different will interact with a different application. It can be mobile, anywhere, and this application will interact with API gateway, and API gateway will interact with the different APIs or microservices that are in our APIs. And another example If you have more complex application, maybe you need more than one API gateway. So you need to be careful when you implement the API gateway pattern. Usually, it isn't a good idea to have a single API gateway aggregating all the internal microservices of your application. If it does, it acts as a monolithic aggregator or orchestrator and violates microservice autonomy by coupling all the microservices. And we will present now just to finish with a solution where we are able to use API gateway pattern, that is Azure API management service. All providers have their own API gateway, and this is an example in Microsoft. It's Azure API gateway that is hybrid, portable, multi-cloud management platform for APIs. It provides providing as core functionality the assurance of a successful API, let's say, program through developer engagement, business insight, analytics, security, and protection. So you see here that we have multiple platform, multiple functionality features for developer, for the user, to upload your API, for management. It's really simple to use. And we have API Gateway, Azure Portal, Developer Portal. So this diagram presents really different component of an Azure API management. And to finish, so I recommend to see my book here. It talks more detail about the API patterns and how you are able to modernize your solution by adopting APIs, using API gateway patterns, and how you can use Azure as also API management service. Thank you for joining me. And you can scan the first one, and another book it's about also about modernizing your solution, but it's another concept with a containerize your APIs in using containers, a different solution.